Good. I'm your professor, Francis Schmidt. This is 3D Animation 1. Um, we have two professors. We teach a different section. Rajiv Shah teaches a different section. Um, and you can use all the resources of both of us. What I want to do today, actually, is I'm going to cover the basics of what 3D animation is and how you'll use it. And then Rajiv has a different video that'll cover how you start to get into this program Modo. Um, and then we're going to talk about an assignment for you guys. Your first assignment, so you know it, is going to be to model a piece of food photorealistically. So what you need to do is you need to find yourself a piece of food, and then you're going to take a picture of it and you're going to put it in the homework channel to see if it's okay. What I would normally do in this case is I actually generally use gummy candies um, for a few reasons. They're good to model, and they don't go bad, which is a big difference, and they're cheap and they're sort of disposable. Uh, I'm looking for something similar like that for you because you need to get into you need an entryway into 3D. And the entryway, I think that's the best way to go, is to start with something real. In this case, you'll see, this is a gummy mouse. Oh, we're seeing right through him, though. That's my green screen. That's my fault. All you can see his tail. But this is a gummy mouse. Go in front of him and light him differently. Um, I would take a picture of this and put this in the homework thing, and this is the thing I'm going to try to model photorealistically. Um, if you have a gummy mouse, you could use that. But if you don't have a gummy mouse, you can get some other piece of food. Um, the reason I'm going to have you put them in the homework channel is because we need to see that they're complicated enough. For example, an orange is probably going to be too simple. Um, a steak is probably going to be too hard. Now, the other problem is a steak is going to go bad. This might take us 4 or 5 weeks to figure out how to make this photorealistically. So when we look here and we look at what we get in the 3D program, you'll get the same thing. So you need something you can hold on to, you can look at from different angles, that's not going to go bad over a long period of time. We'll get to that as we go. If you remember, I sent you guys a link to a documentary of sorts. It's an old Simpsons episode, Homer 3D. And the reason that I did that is one of the first things you have to think about. Homer cubed is actually it. I'm gonna just to show you it. It's there. I believe if you go to Drive, yep, we'll go there. You should get it. And it's, Jesus Christ. It's an old Simpsons episode from the Halloween thing when Homer leaves the two dimensions, which are X and Y that he lives in and everyone else does, and gains what we live in, which is in and out, the third dimension. Now, one of the reasons I'm showing this to you, and you should look at it, is that that's a really important concept. The only difference between this program and every other design and animation program is one extra dimension. We're used to X and Y. If you were in high school, you probably took geometry and you dealt with X left and right and Y up and down. The thing that differentiates 3D animation from 2D animation is one extra dimension, Z, which is in and out. But that extra dimension makes everything much, much, much harder. And that's why this takes as much effort and time as it does to figure out how it works. It's funny, there's a term, the term is geometrically more complicated. When we add that one extra dimension, the Z, we don't need twice as much stuff. We need 4 to 8 times as much stuff to properly work with just that extra dimension. And that's one of the reasons why this interface is as complex as it is. Now, I'm going to cover a couple details that Rajiv made as well, but they're very important. One is your mouse. This is my mouse. I think I paid, I don't know, $14 or something like that for this from, I want to say, probably Amazon. That's where I look for these sorts of things, right? Here's what the 3 buttons are. That's your left button, the wheel is your middle button, and that's your right button. And you need to have a 3-button mouse. If you don't have a 3-button mouse, go buy one. They're not expensive. This works on Mac, this works on PC. I'm going to show you this because it will give you some idea just how important I think it is. Did I close my browser? Probably. Here's a browser. Here's Amazon. Not saying you have to use Amazon. You can use whatever you want. But if you used Amazon and I looked for a 3-button mouse, Mac, Amazon Basics 3-button wired mouse, $7.50. $7.50. You could have it by Sunday. So you got no excuse to not have a 3-button mouse. Now, why am I being such a, stickler about this? Well, you get those extra dimensions, X, Y, Z, and you need the 3 buttons. When you're using a 3D program, it's very important you have one hand on your mouse, left, middle, right button, and the other hand is going to be on this, which you also need, your keyboard. If I can get the angle of that right to not get it so. Now you'll note my keyboard. You'll sort of note my keyboard. That's a better way. We'll get the light on it there. My keyboard has a keypad. That's important. You want something with a keypad, and it's a full keyboard. Now, you're used to typing papers and stuff like that on it. That's not what you do with 3D on this. To work in 3D, you're going to use this as a control pad. Each button is going to have special features attached to it. And the more buttons you know, the faster you'll be able to model in 3D. So anyone who's working in 3D generally has one hand on the keyboard and one hand on the mouse. And this is a place right away where a 3D program is very different than a 2D program or a typing program or any other thing like that. This is the best way to model, and the way you're going to get fast in 3D is by learning keyboard equivalents, which are what buttons actually cause what things to happen on screen, and having one hand on your keyboard and one hand on your mouse at almost all times. Okay, you're going to get your keyboard, you already got your mouse, you hopefully got your Modo. They give you that 1-year free license, which is good. It's an expensive product. Here's a thing it's worth understanding so that you'll know at least at one point in your life someone told this to you. What they're trying to do over there, and one of the reasons why these programs are so complex, they're trying to simulate everything. Like that over there, that 3D program, that is a reality simulator and then an unreality simulator. We're supposed to be able to make anything you could possibly imagine and anything else in that interface. So the question becomes, well, how do you do that? They decided to use geometry, and they decided this a long time ago, in the probably mid-1960s or so. And if you remember in geometry, there's an element. There's a most basic element of all 3D, well, of all geometry, basically. I'm going to go back to high school geometry for you. I'm going to click this arrow up here, which is going to give me the 4 screens I'm going to need, and I'm going to click this arrow here, and this is a piece of graph paper from high school. Okay, I have an X dimension, I have a Y dimension, I have a 0 point, I think it's called an abscissa, I forget, something like that. When you were doing geometry, there was a very basic thing, and I'm going to make one right now that it all started with. I'm going to put one right here. That is a point. That's the most basic element of geometry when you're in high school. A point has no size, it's just a location. In this case, the location is 1 on the X and 1 on the Y. Now, If I put a point anywhere else, except on that point, I'm going to get something else. I'll put it up to here. That is a line. If I have 2 points and I connect them, they form a line. Now, if I put another point anywhere and connect it to those 2 others, except on that line, oh damn, I got the wrong one. I would get what would be a shape. Although, well, let me go to my tool properties here. I'm actually going to undo my way out of that, Control Z, one of those keyboard equivalents. I'm going to make sure I'm making polys here. We'll go to there, there, okay. That shape is a triangle. A triangle is the simplest type of polygon. So, everything you've ever seen in every 3D movie, every 3D video game, the way that they make those things is they take points, they connect them with lines, they then turn those lines into polygons. And then the polygons form the actual shape of what's going on. And you're going to hear me use the 5 parts of 3D animation a lot, because everything you've ever seen that's 3D animated had to go through 5 distinct functions. One is modeling, which is where you actually put the geometry together. 2 is shading and texturing, where you make it bright or red or clear or shiny or reflective. 3 is the actual animation. You move it all around. 4 is cinematography, where you set up cameras and lights so that you can see what's going on. And 5 is actually the most important of all, rendering, where you take all that information and have it spit out, strangely enough, 2-dimensional images that show you what happened. So we're going to start in modeling, which is where most people start. Anybody I know who's gotten good at 3D, the way you do it is you cannot possibly know all those things. It's too much. If you look at a 3D movie and look at the credits in the end, you'll see a whole department of people who are modelers, you'll see a whole department of people who are texture and shading artists, whole departments of animators, whole departments of cinematographers, and whole departments of render wranglers. So the way you get that job is you pick one of those 5 things and you get really good at it, and you learn just enough of the others to produce a short animation. So if I'm into texturing, I want to work really hard on making my textures look realistic, but I'm not going to work too hard on modeling or animating or the other stuff. If I'm into modeling, my models are going to be perfect, geometrically ideal, but I'm not going to work too hard on shading or the other stuff here. This whole industry is based on demo reel. Nobody could care less what school you went to. The only thing they care is that you have a demo reel and show them that you can do what they need done. And then they might look at your resume. So the thing you have to be most concerned about right now is learning enough of this program in one of those areas so that you can produce this short animation to make the demo reel to get the job or go on to the other school. Now, I want to get back here again because I want to get us into the 3rd dimension, which we're not in yet. This is still 2-dimensional. This is X and this is Y. Now, here is where it gets more complicated. I want this other dimension, this Z. I can't get it here. No matter what I do, there's only 2 dimensions. So what I need is I need another piece of graph paper. I'm going to click that like that. And up here, which is the one we were on, let me go back to it. It says front, because it's the front. It says X and Y there. By the way, remember my mouse buttons? Right click, middle click, left double click. It tells me what those 3 mouse buttons do down here in the bottom. So this is the front piece of graph paper, X and Y. I need a piece of graph paper that looks down on this thing that I can fold up. Much like this. This is top. So this is now looking X, actually this way. It's looking X and Z, and then folding it up. If I click here, I'm in the 3rd dimension. Now we have another problem. Let's say I want to get on the side of it. I need another piece of graph paper, which is this one down here, right? And if I click it, I can do left too. You see they're all in there? I'm going to, if I hold down my Alt key, and you can see, I should point out on our display here, besides me, the guy talking to you, we have the mouse, and you'll see when I click left, middle, right. You'll even see when I use my wheel up and down. Then we have the keyboard. Anytime I click something on the keyboard, you'll see me doing it, and you'll see anything I click will cause stuff to happen. These are the keyboard equivalents I'm talking about. One of the things that's important is the Alt key. When I hold down the Alt key, it lets me move around in whatever window I'm in. So this is my front view, this is my top view, this is my right view, which are, just because I added that Z, I need these, right? Here, we'll do that over there. And then, here's the really weird part. Those three pieces of graph paper don't really mean anything to us because they're just mathematically correct things. We want what things look like out here. And out here, in the world we live in, points meet in the distance. Parallel lines, I should say. That's weird, by the way. You don't think it's weird because you've spent your entire life sitting on a train track. I mean, not on the train track technically, but if you're on a train track and you look down the rails appear to meet in the distance, and you probably never gave it a second thought, and why would you? That's the way things look. But it's not right. We know full well that parallel lines don't really meet. So we have to simulate that view. That's the perspective view over here, which if I go here, is the one we want to look at. And you'll notice it's showing me graph paper down here. Now, when I hold down my Alt key in just the perspective view, I can rotate around. See that? If I roll my middle mouse button, I can zoom in and out. And if I hold down Alt and Shift, I can move around. That's panning. See? Alt, Shift, pan, Alt, rotate. And you'll notice Modo always has those pieces of graph paper floating around for me so I can tell where things are. This is really important if you want to design something complex. If you model here, here, and here, it will always be right here. The opposite is not true. If you model in the perspective window, it can be wildly off in these other windows. You should always be willing to go back to these flat plane views to make sure what you're making looks correct. That's a really important part of it. Okay, I'm going to click this guy back there to blow this screen back up. And you'll see we basically, we could build something out of this. We could put in points and lines and put them together. It would take a really long time. It would be very difficult and unpleasant. That's why the first type of modeling, I should give you a little bit of history behind this. Modo is one of the only 3D programs that was made in the 21st century, which is interesting. It means they took 30 or 40 years of history and then they applied it to creating a new program just for making geometry. Most of the other programs were designed back in the 1980s, 1990s, and before the programs, they used to just write code. They used to write code that said, here's a point, X, Y, Z, here's another point, they're connected. Write code to like make the polygon, to move them, to do all 5 of those things. And then they would render them, which could take a few days, and they would actually have to print them on the film, and they would go get the film processed. And then they'd sit in a theater and they'd watch it, and it was wrong. So they'd have to go back to the code and figure out what was wrong, and then write all that code, and then go through that process again and again. Very long, difficult process. They realized very rapidly that they were always using certain shapes over and over again. This is an old horn, and you'll see it's got a cylinder and another cylinder and a cone, and it's got, well, some hexagons for these bolts. These are basically just boxes. I could make this if I had those basic primitive shapes. And the thing is, a cube is a cube is a cube. A cube is 8 points. So if I write the code for cube once, why don't I just put that out there and then not have to put in all that individual stuff? That is the idea of primitive modeling, which are these shapes over here, the primitives. I'm going to click one. I'm going to pull it out. Notice X, Y, Z, red, green, blue, those 3 things again. This was the first modeling technology. I believe that Rajiv's video picks up from here. And he talks about how you can put in primitives, how you can move things around, and how you can start to build things over there, over here actually, in the item list, which is another part of this whole thing. So I'm going to send you a link to that video, the video Rajiv made. And I would like you, after watching this, and if you have any questions, of course, you can always ask, look at Rajiv's video and then start to build things out of primitives. Meanwhile, find what you're going to model photorealistically and put a picture of it up in the homework thing. I'll do the first one so you can see how that goes. Okay? Good. I'm going to, I'm going to just make sure that we're in the right, there's my classroom too, here's this. I'm going to step out. Again, you have questions, you can always ask me. You can also ask our tutors. We have both Eddie and we have Eddie, but that's okay. We can talk to the other ones too. Anyway, and you can always ask me as well, okay? Okay, I'm stepping out here, guys.